Hi friends, we're going to be talking about the 3.1 lesson, Introduction to Polynomials and Operations with Polynomials. So we're just going to try to figure out what a polynomial is. You've seen a lot of them before. We'll try to figure out some patterns. So these are all different polynomial equations here. What are some things you notice? See a lot of like x to the powers, stuff like that. Over here, things are not polynomials. So I have x to the powers, but what's different about these powers? Oh, these are fraction powers. Over here, these are whole number powers. Wait a second, but I have a fraction here. Okay, but those are just constants. Those aren't powers. And when I divide by 2, that also makes it a power. That also just changes the constant. Okay, here's an x to the fourth. Oh, it's on the bottom of a fraction. We don't have any x's on the bottom of fractions over here. Over here, you have square roots. Okay, so what are some things you're noticing? So polynomials are all going to have x to a positive whole number power. Yeah, and nothing that we never divide by them. Okay, let's look at the graphs. How do the graphs compare? Yeah, a lot of cool squiggly lines going on. They all seem to be going on forever. Okay, things are not polynomials. Okay, this one, it just goes back and forth between two numbers. This looks pretty similar. Why is that not polynomial? Let's zoom in even more. Okay, I see some reasons. Over here, see I have a big jump. That's not the same over here. There are no jumps over here. Okay, on this graph and this graph, I have that sharp corner right there. Do you see that? All of these are smooth corners and smooth changes. And I think that is the difference of this one right here. Can you zoom in big enough? Yeah, I think we have a sharp corner right there. Whereas over here, it's like smooth. Okay, any other changes? What about this last one? Okay, this one only exists from 0 over, whereas our polynomial graphs, we only see part of them, but we know they're going to keep going down forever, going up and sideways forever. Something that's cool about the polynomial graphs, let me not zoom in so far anymore. It's zooming so slowly. Okay. So how can you tell if it's not a polynomial? So things that are not, make it not polynomials. Let's see, polynomials, you have the domain for all polynomials is always negative infinity to infinity. These ones over here don't have that same, don't have the same domain. Like this one, we only have domain from 0 to infinity. This one, we don't have domain between those two numbers. So a polynomial will have infinite domain. Also, a polynomial will have smooth curves. This is a calculus thing you'll learn later, but if there's a sharp corner, that means it's not differentiable. But you'll learn about that later. Don't stress about it for now. So we can tell by the graph if it's a polynomial. So basically a polynomial is a function where you have x to the power, and that power is a whole number and it's positive. And so anything like x to the third, x to the 27th, x to the 2 millionth, those are all going to be polynomials. And what's cool about polynomials is it has an infinite domain. You can plug in any number and you'll get out an answer, which is awesome. We use them a lot and they're pretty easy to work with. We use them a lot to model real life situations in a lot of different things. You can use a polynomial to model practically any equation, which is awesome. Which is why we like polynomials. So there's some vocab that we'll talk about. We're talking about polynomials. So one of the vocabulary words is this word degree, and that means the highest power. So let's write that down. Degree. Let's go with blue today. Degree is the highest power. So what is the highest power here? The biggest exponent. Okay, it's that 3 right there. Because 2 to the third is bigger than x to the third is bigger than x to the first. So this is degree 3. How many solutions do I have? When I say solutions, I mean how many times is this equation going to equal 0? So when it equals 0, that means y is 0. So this is the y-axis. So this is like y0, y1, 2, 3. So where is y equal to 0? Where does it cross this line? 1, 2, 3 times. Wonder if that was an accident or on purpose. Very interesting. Okay, and what is the leading coefficient? So basically what that is, is the coefficient or the number multiplying the highest power. That's what a leading coefficient is. So what is the leading coefficient in this case? Well, for us, that will be 2. The other thing I'd like to talk about is the end behavior. So let's look at what this says. So this looks scary, but it's not. It's the limit as x goes to infinity of f of x. So if I plug in really big numbers for the x, what happens to the y values? So I'm plugging in bigger x's. See how the graph just shoots up? So I can say that that's going up to infinity. Let's look over here at this graph. The limit as x approaches negative infinity. So as I'm plugging in small numbers in the x's, what's happening to the y? Okay, we can see it's going down. It goes to negative infinity. Let's try again on this next one. So we have this graph, x to the 6th minus 3x to the 5th plus 6x cubed minus 3x squared minus 3x plus 2. So let's talk about these solutions. Let's talk about the degree. The degree here is 6 because 6 is the highest power. So it doesn't matter that we have this 3 or that 6. It's 6 because of the highest power, degree 6. How many solutions do we have? We have 1, 2, 3 solutions. We'll talk about it more later, but this graph actually, another way to write it is I have x plus 1 squared times x minus 1 cubed times x minus 2. And here, we'll talk more about this later. This is just a quick glimpse. So we have this solution of x equals negative 1 twice. So it's 2 solutions. And then here I have the same solution, x minus 1 cubed. So I have that same solution 3 times. So 2, 3, 4, 5, and I have the solution once. So that actually makes it 6 solutions. So we'll talk more about it later when you have multiple solutions, what that means. But do you notice a pattern? Degree 6 solutions? Interesting. And what is the leading coefficient? So what the highest power was x to the 6. So what number is being multiplied? There's not one you can see right away, but there's always that implied 1. I'm always saying, there's always the 1 right there. So our leading coefficient in this case is 1. Let's look at the end behavior. So what happens to y as x gets really big? So as I'm plugging in x numbers, they're getting really big. Y goes up. So this goes to infinity. What happens when I plug in x numbers that are really small this way? Y still goes up. It goes to positive infinity. Okay, now we're going to practice adding and subtracting polynomials. So basically all I have to do is combine like terms. So combine all the x squareds together, combine all the x's, all the numbers, etc. So here are 3 functions, f of x, g of x, h of x, and k of x. So to add f of x plus g of x, we're going to add these together. 3x squared minus 4x plus 12 plus g of x. X squared plus 5x minus 3. Okay, so let's add my x squareds first. So I have 3x squareds and 1x squared. So now I have 4x squareds. Here I have, let's get color, negative 4x's and 5x's. So add those together. Negative 4 plus 5 is positive 1. So I have 1x. And then we have 12 and 3. And 12 plus 3 is 15. Excuse me. Ooh, I did not write that very well. That is a 15. And that's all I have to do to add them together. It's not that hard. Should practice the subtracting one. So I have g of x minus h of x. The only thing you have to remember when you subtract is to subtract all of h of x. So I'm going to put a big parentheses here. 2x cubed minus 5x. I like to distribute the negative so I just don't forget it. So I have x squared plus 5x minus 3 minus 2x cubed minus the negative is the same as adding plus 5x. Okay, so now I can just combine those like terms. So I can count my x squared. I don't have any x squareds, so I'll just leave it as x squared. Then I have 5x and 5x, so I have 10 x's. And I have negative 3 and nothing else. And then I have a negative 2x to the third. And there's no other x to the thirds. And because this is a positive x squared, I can put a plus sign right there. Okay, and that's how you do it. For simplicity of this video, I can just go through and do it really quick. Not that hard. K of x is this one right here. 9x cubed plus x squared minus 2 minus h of x, which is 2x cubed minus 5x. So let's go ahead and distribute that negative to both of them. It's like I'm timesing this by a negative 1. So I have 9x cubed minus x squared minus 2 minus 2x cubed plus 5x. So I have 9x cubes and negative 2x cubes, so I put them together and we get 7x cubes. I just have 1x squared, that negative x squared. And then I have positive 5 plus 5x. I have positive 5x's, and then I have minus 2. Typically, the standard order is to write it with the powers decreasing as you go. That's why I like to write it in that order. And then f of x plus h of x plus k of x. Ooh, a lot of things to add together. Another way to organize your work is to write them vertically. So I'll show you that. How to do that. So we have 3x squared minus 4x plus 12. H of x right here. So I'm going to line up all the variables. So that negative 5x, I'll write it under the x's. And then I have 2x cubes. And here I have 0x cubes above. And then k of x, I have 9x cubed minus x squared minus 2. And we're going to add them all together. So we're just going to combine like terms. So if I add all of the x cubes up, we now have 11x cubed. And here I have 3x squared and negative x squared. So that gives me, positive 2x squared. Negative 4x, negative 5x is negative 9x. And then 12 minus 2 is positive 10. And that's how you do it. That's how you add them up. Not too hard, right? Okay, now we're going to multiply. So if I just have a constant times it, we times both numbers by what's on the inside, right? So we get 3x squared minus 6. So it's important that we multiply the 3 by both pieces inside. And that applies even when I have a binomial. I multiply x by both pieces. So you get x squared plus 2x. And then you multiply the negative 4 by both pieces. Negative 4 times x. Negative 4x. And then negative 4 times 2. You get negative 8. So I'm going to put them together. X squared minus 2x minus 8. Not too bad, right? Another way you can show it, which I think is fun to do, is an area model. So if I had let me show you what I mean by that. So I was doing 11 times 7. Well, I guess that one's not too hard. What if I do 13 times 7? I don't know that off the top of my head. But I know that 13 is 10 plus 3. So that's 13. Okay, times 7. Sorry, that's not super accurate. 7's got to be shorter than 10. Okay, that works. Because if I said 13 times 7, you could say that's the area of this rug, right? Okay, well, I don't know what 13 times 7 is, but I know 7 times 10 is 70, and then 7 times 3 is 21, and now I can see really easily that 13 times 7 is 90 plus 21, which is 91. Okay, so now how does that work with binomials? So we can do a similar model. I can say I have x, then minus 4, and we don't know how big x is, so I'm just going to draw a random space. And then our negative 4 will be in this box. And I'm going to do the same thing over here. So I have x, and then a positive 2. So now in this time we have 4 boxes. So this box right here, I do the length times the width. X times x is x squared. I have this length, which is x times the width, negative 4. So I have negative 4x. Here I have x times 2, 2x. Here I have 2 times negative 4, which is negative 8. So I add them together. Oh, do you see all these pieces? X squared, 2x, negative 4x, negative 8. You add them together and we get the same thing, x squared minus 2x minus 8. I like this method for, especially when things start to get more complicated, like you will see below. So let's practice. If you want, you can do it both ways. You can just multiply everything together. I'm just going to show you the area model. Well, I'll show you both. So we have x squared times x, which is x to the third. X squared times 2 is plus 2x, negative 3 times x, negative 3x. Ooh, I'm sorry, that should be 2x squared, huh? And then negative 3 times negative 2 is negative 6. No like terms, can't combine anything. That's your answer. Or we could do area model. X squared, and I know this box is negative 3. I'm not very good at drawing things accurately, so please forgive me. And this side of the box is x, and this side of the box is 2. So find the area of this box. I do the length, which is x, times the width, which is x squared. So I get x cubed. And then x times negative 3 is negative 3x. And then 2 times x squared is 2x squared. And 2 times negative 3 is negative 6. You see, those are all the same pieces we had up there. So I love this method for when I have like a trinomial or something. So let's do x squared minus 6x minus 2. Here, let me draw my box. We have x squared, negative 6x plus 2. And over here we have x, and we have a plus 3. Okay, we'll find the area of all this. So x squared times x is x cubed. Negative 6x times x is negative 6x squared. X times 2 is 2x. 3 times x squared is 3x squared. 3 times negative 6x is negative 18x. 3 times 2 is 6. So this equals x cubed minus 6x squared plus 3x squared minus 10x. That's a 10. Plus 2x plus 6. So I can combine these terms and these terms. So I get x cubed minus 3x squared minus 8x plus 6. Other way you could do it is, again, you can multiply them out to each piece. So you have x squared times x. Oops, sorry. I pushed a weird button on my pen. What is going on? There we go. No, stop it. Okay, I'm going to try refreshing the page to see if that helps. Reload. Reload. Sorry, my pen's being weird. Okay, I think you're better now. So multiply each piece together. So x squared times x squared is x cubed. And then x squared times 3 plus 3x squared. Negative 6x times x. Negative 6x squared. Negative 6x times 3. Negative 18x. I can't remember the handwriting. That's 18. So this is 18. So negative 18x plus 2x is negative 16x. Sorry, I'm bad. And then last step, multiply the 2 by everything. 2 times x is plus 2x, and then 2 times 3 is plus 6. So you get all the same pieces. It's just another way to organize your data, which I think is super helpful. Oh, man, this is a long one. Okay, it's the last one, though, so we will do it. I'm going to do the box method. But you can distribute all of them out. Just make sure you multiply the x cubed by all 3 of these pieces. So you may be wondering, why are you giving us such a hard problem? Just so we can practice, make sure you are so solid. If you can do this problem, you can do the easier one super fast. So we have x squared minus x minus 1. And over here, we have x cubed is the length on this one, minus 3x squared plus x, and then minus 4. Okay, let's multiply them all out. Ooh, this is going to be huge. X cubed times x squared is x to the 5th. X squared times negative 3x squared is negative 3x to the 4th. X squared times x cubed. X squared times negative 4, negative 4x squared. Negative x times x to the 3rd. We have negative x to the 4th. Negative x times negative 3x squared is positive 3x cubed. X times negative x squared. Negative x times negative 4 is positive 4x. Negative 1 times x cubed, negative x cubed. Negative 1 times negative x cubed is positive 3x squared. I'm sorry, I said that wrong, but this is the right answer, 3x squared. X times negative 1, negative x. Negative 4 times negative 1 is a positive 4. And we just got to combine the like terms together. All those. When we do that, we get x to the 5th minus 4x to the 4th. Sorry, 1 second. Minus 4x to the 4th. Negative x cubed, positive x cubed cancel, so just have plus 3x cubed. Negative 5x squared plus 3x squared, so it's negative 2x squared. Negative x plus 4x is plus 3x plus 4. And there you go. We did it. So that's how I do operations and multiplications on polynomials. Good luck.